Hello everyone, welcome back to On Prep. Today we are discussing one of the important and frequently asked interview question, which is designing Twitter system. Along with that, we will be covering other social media platform like Instagram and Facebook, where user post a tweet or message and system provides the confirmation to the user that their post or message is saved into the system, and also their followers will receive in their timeline that this user has posted some information in the social media platform. As always, for any system design interview topic, I suggest this 7-step approach. We will go each of these steps in detail one by one based on the available time for the system design interview, based on the role which you are applying for. With that, let's get started with the step 1 for getting the core functional requirement of the system which is expected to build as part of the system design interview. Let's start with making a note of the functional requirement, which is also the core functionality of the system which it must support. User should be able to post the tweet, view the timeline or feed, like a specific tweet, comment on tweet, follow and unfollow other users. This is the core functionality of the system which we are trying to build within 45 minutes to 60 minutes in a step-by-step approach. So our next step is making a note of the non-functional requirement, which is also a quality of the system. As part of non-functional requirement of the system or the quality of the system, we want low latency on viewing the timeline. With that, talking about the cap theorem, we wanted high availability of the system over consistency. What does that mean is, when any tweet has been created by a user, it's okay for the followers to receive those information in their feed with some delay, but we definitely do not want it to compromise on loading the feed or home page for those users. Next, when user is creating a tweet, we wanted high consistency over availability. That means if user is creating a tweet, we wanted to focus more on the consistency or kind of a guarantee from the system to the user. If they have created a tweet, the system saves these tweet into the database and then provides the confirmation to the user that your tweet has been saved into the system. We do not want to save the tweet into the database asynchronously. That means user creates the tweet and it just get the confirmation from the system but has not saved that information in the database by that time. That is asynchronous versus synchronous communication for saving the tweet. We wanted synchronous communication for this particular use case. Let me make a note here for better clarity. We want high consistency for creating tweet and we wanted high availability for viewing the timeline. So far we have talked about the low latency and the cap theorem. Next we can get into the back of the envelope calculation and the storage requirement. Similar to my previous video on Book My Show or Ticketmaster, if you are interested for back of the envelope calculation and the storage requirement, I would highly recommend to refer my Book My Show system design video. But at the end, here you will know that what are your TPS or number of requests per second you would need in your system for creating a tweet, viewing the timelines, and how much storage you would need for saving this information into the system. And you would need a distributed system because the systems like social media, there are generally millions of users or billions of users across the globe who on a regular basis view their timelines. We can say 10% of the users post the messages or tweets into these systems. We can make the assumptions about the users in the system, which are, let's say, daily active users. We have 100 million, on which every user view their timelines or news feed daily, and out of that 10% of the user, which would be 10 million user, creates or post the tweet into the system. To know, ultimately you would need a distributed system, but check with the interviewer. If the interviewer is really looking for you to do the back of the envelope calculation, you should also consider the storage requirement of the system. Let's say each of the tweet takes 1 kilobyte of storage, and let's consider we keep the data in the hot storage for next 5 years. Then how much data would you need? Check out my book my show video to get into the exact calculation for this particular use case. I would highly suggest go with a very high level numbers, and if really required, you can get into these calculations in your deep dive. By now, you should have covered the requirement gathering for functional requirement and non-functional requirement within 10 to 15 minutes. Let's get into step 3, which is database schema design or core entities. While thinking about the core entities of the system, let's look at our core functionality. So let's say we have user, we have tweet. Users are also liking and posting the comments on the tweet. So we have like, we have comment. Users are also following and unfollowing other user. So we have some relationship between followers and followee. So let's call this entity as relationship. Let's get little bit detail on these core entities. Starting with user, we need the user ID, name of the user, we need phone number, email address of the user. For Twitter, we definitely need the tweet ID, the user who created the tweet, and the time when the tweet was created. I'm skipping the time attributes because the created time would be required for all these entities. The time where user is created, Twitter, the like, comment, and relationship been established. We need not to mention these attributes in every other entity. Other than the tweet ID and the user ID, we must need the text of this tweet which user is posting. And if we have the multimedia, so we can have a multimedia content. As of now, we are not sure how are we gonna store the content of the multimedia into this entity. That we would like to touch upon when we go into the deep dive. For the like entity, we will need the like ID when the tweet is liked by followers, and the user ID who likes this tweet and on which tweet this user has liked. So we need the tweet ID. For the comment, we would need the similar attribute. So let me copy and paste it here. Other than the like ID, we would need the comment ID here, and this would be similar to the like entity. The users are commenting on a specific tweet, which user and what is the comment ID. In case of relationship, there is a relationship established between two user when user A is following user B. So we must have both the user IDs in our system. So we will have a follower ID and followee ID. We also need the relationship ID, which is the primary key. So now we have two users defined here. This is a foreign key for this relationship entity, and these IDs are basically the user IDs, which will be the primary key for the user table. So let's say if we wanted to perform that for this user ID, how many followers. For our understanding, this followee ID is the celebrity ID and the follower ID is the fan ID. So if I am the celebrity, this is my user ID, and I can see for my user ID, I can put a where clause and get the number of rows where my ID is equals to the follow ID into the table, and I can get all the followers with this query. Similarly, when we wanted to make a count of how many likes being exist in our system for a particular tweet, we can make a count for like how many records exist into this table for a particular tweet. Same applies for comments. Here we can get the list of comments for a particular tweet. As you can see, these are the foreign keys for these entities like comment, like, and this is actually a primary key for the user table. So user ID is a primary key for the user table and it's a foreign key for these tables. Tweet ID, which is the foreign key for the like and comments table. So now you're able to establish the connection between these core entities, and that's how you started to put these information into the system. Next we need to go to step number 3, which is our API design, where we wanted to show how are we gonna expose these information or make this information available for our users. Let me make some space here. Step 4, which is API design. For that, let's look the core functionality of the system. User should be able to post the tweet. So we need post API for our system. API tweet post. What do we need for posting a tweet? So request is an important parameter here. We must have the user ID who is posting a tweet. Let's say user ID is 123. We need the text, say ABC. This is the text or content which user is posting. If there is a multimedia, we need the multimedia content, but when we go into deep dive, we will see that it is not a scalable system to put a blob for each of these rows, and we would need to have this into our some storage bucket like S3, and here we will be providing the URL link for that specific storage. But as always, we go with the simple design in the beginning, and as and when we go into deep dive, we keep improving these API structures, and the same applies for the schema design as well. Let's go to the next requirement of the system, which is view feed for the tweets. This is a read path of the system, so we need a get API. By the way, this is the right path for the system. That's why we had a post API for posting a tweet into the system. This is to get the timeline for a specific user. So we need the feed view API. The response would contain the list of tweets. Let me mention here list of tweets. And how can we serve the list of tweets as an array of tweet, and this is how you would represent the array in the JSON structure. Each of the array item would contain the tweet ID. As such, if you see with a very bare minimum core functionality, you would need the tweet ID where you would be able to show the tweet details, and you would need the count and comments for that specific tweet, and this is how you would need the list of the tweets. Next requirement is liking a tweet and commenting on the tweet. This is a right path for the system, so we need the post API. This post API would have API if user is liking a tweet, we need to have, say we have user ID 123 and then tweet ID. So which tweet user is liking? Let's say the tweet ID here is 456. Okay, and actually we should not have the user ID as part of the request in the API. The reason is any user can manipulate these user ID. Let's say some other user B, would be able to like a tweet on the behalf of user A. That's why if you see, I have not added user ID explicitly as a request as part of any of these API. So let's remove the user ID here, and we should have the user ID either as part of the header or the user token. So that is a standard format for all these REST APIs. So let me mention here that user ID should be part of the header or user token, which is more secure and safer for adding the user's ID, like because this is always linked for a specific user for any of these APIs. So I should not be able to post a tweet, like or dislike or comment for any other users. So that's why this information is kind of hidden for the clients. Let me create some space here and zoom out these APIs so that we can get this space for our comment and follow user. So let's say we have a like. Similarly, we will have the comment API as well. But yeah, user can like or dislike as well. So let me also mention here for a particular tweet user, what is the action here? The action could be like or dislike. Also, let me copy this post API, which is similar to the comment API here, and let me zoom out a little bit and keep it here. The post API for the comment is similar to the like dislike API. For a particular tweet, the text would be, let's say it is XYZ. So if you see here, user is commenting for a particular tweet with this text, and the user ID is abstracted for the client. Similarly, user is liking a particular tweet, and here user is able to view and post the tweet. Now the last core requirement for our system is follow and unfollow user. This is also a right path for our system when user A is following user B, and we wanted to save this information in our system. So we need a post API. Let me generalize this API. What I mean is, for our Twitter system, we have the relationship. What is the relation here? So the request for this API would have the follower and the followee ID. Let me mention the follower ID. Say 111 is following 222. So this is a user ID. Let me move little bit up and zoom out. So now you should be able to see the complete structure of this API. So here this is, we are saving this information when user is following a particular user. We will be able to make these relationship and create the timeline for user A or user B. Let's quickly check if we are able to cover all the requirement. So this is how I suggest, whenever you are creating the schema design or API design, keep revisiting your core functionality of the system and how you wanted to implement or expose these functionalities for the client to make use of. We have covered posting a tweet, viewing the timeline, liking, disliking and commenting, following and unfollowing the users. Basically, we have covered the technical aspects to fulfill the core functionality of the system, And now we need to connect the dots between these technical terms, how we wanted to store this information into our system, and how do we wanted to expose this information for the clients to make use of. So let's get into a high level system design.